3 slides. This is going to be a 4-part problem over the next 3 slides. This is a bunch of the lessons combined here. So the first part is dealing with lesson 2.8, inverse. It says, determine if the inverse of f is a function. Give a reason for your answer. So let's talk about what this would look like as a graph. What type of equation is this? Like, is it polynomial, rational, exponential? Those are the equations you learned. Exponential. Would this be exponential growth or decay? It would be exponential growth. Why is it exponential growth? Because the base is greater than 1. Okay, normally I'd say this is the initial value at 0.5. There's one problem with this. We have transformations. Which way would I actually move this? Hey, stay with me. Which way would I move this if it was x minus 2? Right 2 units. So we would go right 2. I'm just going to say right 2. And then what would I do with this? Down 3. So this graph would have an initial value right there. And you said this is growth or decay? Growth. So what does it mean if it's growth? Normally, if it's growth, does it leave the asymptote or approach the asymptote? Leaves. It normally would look like this, but since I shifted it, it would now look like that. There's your graph. Okay, first question. Would the inverse of f exist? Would this have an inverse function, yes or no?
Maybe.
There was a test I gave you when you think about a graph to know if its inverse exists or not. What was the test?
The line test?
Yeah, what type of line test? Vertical tells you if the one you're looking at is a function. Vertical tells you if f's a function. How do you know about its inverse?
Horizontal.
Horizontal. Would this pass or fail the horizontal line test? Pass is HLT. Okay, now listen very, very carefully. Your reasoning for AP Pre-Calc, they do not accept passes HLT. They do not accept that as an answer. Now, I'm going to write it first. How do we know if it is or it does not have a function? It does because, here's what I'm going to write for us. That means f inverse exists. Why? Since f passes what test? The horizontal line test. Now, that doesn't count for points. I'm just writing that down so I know what to write. Here's how you're going to write your answer. If it passes, it only passes because the graph is either always increasing or always decreasing. On this one, does the graph always increase or always decrease? Increase. So here's how you would write your answer. The inverse of f is a function since f is increasing on its domain. So number one, since it's increasing on its domain, since each input is increasing on its domain, each output is mapped to exactly 1. I think that's the words they use. Exactly 1 input value. The inverse of f is a function since f is increasing on its domain, and I should say, and each output is mapped to exactly 1 input value. That's how you describe the horizontal line test. Each output is mapped to exactly 1 input. I'm going to explain this to you real quick. Everybody hold out your hand like an horizontal line. This is a test of outputs. I'll show you why. Outputs is like the y-axis. If you move this line up and down, what are you changing? Are you changing x's or y's? Y's. A horizontal line, believe it or not, tests y values. And so What we're saying here is since f is increasing, since it's going up, your horizontal line never hits the graph more than one place because it's always increasing. Now if the graph increased and decreased, at some point in time your line would hit the graph twice. This is the explanation they want to give you credit. If you want credit, you have to have this explanation. You can't just say this. Now that's what we're describing. This does exist since f passes the HLT. So how do you properly describe it to where they give you credit? You describe it like that. The inverse of f is a function since f is increasing on its domain, and each output is mapped to exactly one input value. That's the HLT right there. That's how you would write that. Now let's go to part 2. I told you this is a 4-part question. In your next slide, we have part 2 and 3 on your next slide. I'm going to copy the graph because I think I'm going to need it on the next slide. I can't remember, but let's check it. Part 2 says find the zeros of f if they, that's supposed to say they, exist. Write your answers as a decimal approximation. Okay, does this have a 0? What does it mean to be a 0? What, class? What does it mean to be a 0? X-intercept. Does this have an x-intercept?
Yeah.
Okay, we will have 1, 0. To find it, we would need the calculator, so open up your calculators. Let's graph it. It should be pretty simple to find. If you just type in your equation. I think on the powers you have to put it in parentheses to make the x minus 2 stay in there. If you don't use a parenthesis on the powers, it always leaves the exponent. So make sure you put a power on that to make it work. How many decimals are required for AP Pre-Calc?
3.
3. A 0 you write as x equals. So we need 3 decimals. I'm going to do the approximately symbol. 4 point, would it be 584 or 585? 585. That's my 0. Great. And number 3. For you, this on the same slide. Just determine the equations of any asymptotes. So we do have an asymptote here. The asymptote is what this graph left. The question is, what value did the graph leave? Normally our asymptote is the y-axis, but this has been shifted down 3. So what value are we leaving? Should be a -3. Test it. Type in y equals -3. Does that look like an asymptote? Does that look like the graphs are holding hands together? Yeah, that would be my asymptote. That's not what I wanted to hit. I wanted to hit this one, sorry. Let me do it as a dash so you can kind of see in between. You can see those graphs are following each other. It is y equals -3. Determine the equations of any asymptotes. I have a horizontal asymptote. That's what that is, horizontal asymptote. Of y equals -3. That's what that value right there did. That was a vertical shift. Shifted it down 3 from the x-axis. And finally, the last part to this problem. So that right there was less than 2-3, that portion. I didn't tell you. This portion right here, we never really talked about that with it, so I don't know what to call that one. But number 4. Let's use limits to describe our end behavior. We have 2 end behaviors here, as you go left and as you go right. We want to talk about what's happening to the function f as we go to the right, and what's happening to function f as we go to the left. That's what it means to be end behavior. What's happening as you go left, and what's happening as you go to the right. Let's start with as we go to the right. What's happening to this graph as we go to the right? Is it rising, falling, or getting flat? Rising. If you're rising, what value is it approaching? Infinity. Okay, over here. Is this rising, falling, or getting flat? What value is it getting flat on? Yeah, -3. We just got that right there. -3. So that would be my 2 in behaviors for that equation. We talked about our limits on lesson 2-3 as well. Right.